So, have you ever wondered if that AI you're talking to is secretly learning from you? Every time you use it, well, the answer might actually surprise you. Today, we're going to pull back the curtain on how these systems really learn, and maybe even more importantly, when they absolutely do not.
Okay, let's start with a scenario. I bet a lot of you have heard something like this. A new AI system goes live, but hey, it's not perfect. It's making some mistakes. And someone, maybe on the project team, tells leadership, it's okay, the model will learn from users. Right? Sounds reassuring. Sounds like a great, elegant solution. But that simple sentence, it's built on a really dangerous misunderstanding.
Fast forward 6 months. What happens? Well, this is what happens when that reassurance hits reality. The error didn't just persist, it scaled. That little glitch is now a huge problem, maybe even a trust or compliance issue, and it's happening over and over again.
And here's the thing that's so important to get. Nothing failed in the technology. There was no bug. The system was doing exactly what it was designed to do. What failed was the mental model. The team just had the wrong idea about how their AI actually works.
So in this explainer, we're going to give you the correct mental model for AI learning. We're going to swap out that flawed assumption for a framework that's clear, that's accurate, and frankly, that's governable. All right, let's dive in.
All right, here's our game plan. We'll kick things off by talking about that dangerous misconception. Then we'll get into the huge difference between training an AI and just using it. From there, we'll look at how AI learns from examples, and also how it can learn through trial and error. And then, this is a big one, we'll cover why production models are usually frozen. And finally, we'll clear up why memory is definitely not the same as learning.
Okay, first up, let's nail down the most foundational difference here. We need to get really clear on what learning actually means when we talk about AI.
So AI learning isn't some vague, magical thing. It's a very specific engineering process. It means the model's internal parameters, you can think of them as its internal wiring, are actually being changed based on data. And this is key. This only happens during a specific phase we call training. If the model's core structure doesn't change, then guess what? No learning occurred, period.
You know, if there's one idea to really lock in, it's this one. Using an AI does not make it learn. Just like reading a book does not rewrite the book. You're just accessing what's already there.
See, every AI system has these two distinct modes. There's the training phase. This is when the model's parameters are actually adjusted with data. It happens offline, it's deliberate, it's a whole process. This is when learning happens. But then there's the inference phase. This is when the model is out in the wild, being used. It's read-only or frozen. It just applies what it already learned to new data. No new learning is happening here. So the bottom line is simple. If training isn't happening, learning isn't happening.
Okay, so we've established that learning only happens during training. So the next logical question is, well, how does that training actually work? Let's get into the 3 main ways an AI learns from examples: supervised, unsupervised, and self-supervised.
First up is supervised learning. The best way to think about this is like studying for a test when you've been given the answer key. You show the model a ton of data that's been manually labeled with the correct answers. A classic example is email filtering. You feed it millions of emails, and each one is clearly labeled spam or not spam. The model's entire job is just to figure out the patterns that connect the content of the email to the correct label. But here's the critical danger with this. The model has no idea why something is spam. It doesn't understand the concept. It's just a pattern matching machine. So if the original labels, the ones made by humans, were biased in any way, the system will learn to reproduce that bias, and it will do it at a massive scale.
All right, next we have unsupervised learning. This is totally different. Here, we give the model a big pile of unlabeled data. There are no correct answers provided. The goal is for the AI to find hidden patterns or structures all on its own. A great example is customer segmentation. You give it all your purchasing behavior data, and it might find natural clusters of customers that you didn't even know existed.
Now here's the limit. Unsupervised learning just surfaces the structure. It finds the groups. It's up to us, the humans, to look at those groups and decide what they mean. The AI can't tell you, oh, that's the high-value weekend shoppers group. It just shows you the cluster. And that brings us to self-supervised learning. This is the real engine behind the large language models you hear about every day. The big idea here is that the model basically creates its own labels automatically. It takes a huge amount of text, say from the internet, and plays a game with itself. It'll hide a word in the sentence and then try to predict what that missing word is.
By doing this billions and billions of times, it learns the patterns, the structure, and the flow of language.
And this simple idea is exactly why an AI can sound so confident even when it's completely wrong. It's not accessing a database of facts. It's just predicting what word usually comes next, based on the patterns it's learned. The result? It can generate sentences that are grammatically perfect and sound totally plausible, but are factually, well, just made up.
Okay, let's switch gears a bit. There's another way AI can learn that doesn't rely on a big, static dataset. It's all about learning through trial and error.
This is called reinforcement learning. Imagine an agent, let's say an AI trying to play chess. It exists in an environment, which is the chessboard. The agent takes actions, it makes moves. For every move, it gets a reward or a penalty. A move that leads to a winning position gets a reward. A bad move gets a penalty. By playing millions of games against itself, it just learns, through pure trial and error, which actions maximize that cumulative reward.
But, and this is a really important boundary to understand, all of this trial and error stuff happens before deployment. It happens in controlled simulations, not during everyday use with your customers. The AI isn't out there experimenting on real people in real time.
So this brings us back to that big question. Why are production models frozen? Why is this read-only mode the default? Well, it's not a limitation or some kind of technical problem. It's a feature. In fact, it's absolutely essential for safety and governance.
I mean, think about it. For one, safety. A model that's constantly changing in unpredictable ways is a huge risk. Then there's predictability. You need to ensure a consistent, reliable experience for all users. And finally, compliance. You need a stable, auditable system for any kind of regulatory review. You can't have the system rewriting itself whenever it wants.
Yeah, a system that rewrites itself in production isn't innovative, it's just ungovernable. It's out of control. And that's not something you want in a business setting.
So you might be asking, okay, but how do we improve the model? Well, that's where a process called fine-tuning comes in. This is a deliberate, small-scale retraining on very specific data. You're trying to adjust the model's tone, or its style, or its behavior. It's not an automatic update, and it's definitely not a way to add new facts on the fly.
I love this analogy. Fine-tuning adjusts the instrument, not the sheet music. It can make the violin sound better, but it can't change the notes it's playing. So if you need your AI to know about today's news or the latest facts, fine-tuning is absolutely the wrong tool for the job.
Okay, we're almost there. Let's tackle one final, crucial distinction that trips a lot of people up. Memory is not learning.
The difference here is absolute. Learning is a permanent change to the model's internal weights. It only happens during that training phase we talked about. Memory, on the other hand, is just about storing or retrieving information within a single session. It does not change the model.
Really, memory in this context is just a long prompt. When a chatbot seems to remember what you said 5 minutes ago, it's because the entire conversation is being sent along with your latest message. So when the session ends, poof, it's all gone. The AI is exactly as it was before you started talking to it.
All right, let's wrap this up with the key takeaways. Number 1, AI learns only during deliberate training phases. Number 2, most systems you use in production are read-only. They are not learning from you. 3, fine-tuning is a planned, deliberate update, not some automatic process. And finally, memory is just temporary information access. It is not permanent learning.
Because once you see exactly when AI learns and when it absolutely does not, everything changes. You stop outsourcing your judgment to the system and you start governing it like a product. And that is how you lead in the age of AI.